course, we joke about it, we meme about it. It's a really hard reality of our lives. But, we have gotten used to it. We expect crazy regulatory changes at any given moment. I say that because that comes before technical skills. Now, of course, you need talent and technical skills and expertise to build, systems. You have to sit and write software. You look at the peers and suddenly, that other organization has 50 people. So we have to hire. We need product managers. We need more developers. We need more dedicated designers.
Okay.
Or we need to build a certain thing. It needs to be able to handle, let's say, 1 million users. Whatever in that, context. Let's go serverless, or let's pick this cloud. That's very top-down thinking.
Yeah.
So it has to be first principles, And, I'd been getting annoyed and I'd been getting frustrated. And that typically is inspiration to, tinker and write something on your own.
Right.
So for unit conversions, I could just write a simple bash script for myself. A lot of force is really altruism, right? Some of the most valuable projects in the world that all of us, billions of people use are made by a handful of people who make it because they like making it. They struggle to make a living with a difficult job, and at the same time they contribute their personal time and effort into a FOSS project that they give out to the entire world for free. Back then it was just me. When we started Zerodha Tech, it was just me. And I was sitting there, I'd go sit with non-tech folks, find the problems, write Python scripts to automate. And at some point, I had too many, people got the taste of automation. It wasn't even tech, it was automation. And the stack has largely stayed the same. It's Go, Python for stuff, Postgres, Redis, Kafka Nats, and all performing what they do best. Our annual bill is probably not even like an Instagram campaign for many startups. That's how low the bill is. At the end of the day, no matter how sophisticated your CI/CD system is, it's a Linux program that is going to be killed or SIG-hubbed or restarted. That's it.
Yeah. Hey, welcome to yet another episode of SCALER Pod. And today we have someone with us that has been very fairly demanded from every episode we have shot till now. People have commented that please bring Dr. Kailash Nadh to the episode. So we have him today. Thank you so much for taking out your time.
Thank you.
Right. So we will, of course, have a lot of things to talk about. I would definitely start off with my pet question that I've been doing for every episode is like, what does a day in your life look like? And then mostly in context of work. And I've gotten very different answers, so I'd love to.
Firstly, again, thanks for having me here. Hearing Dr. Kailash Nadh is a little awkward. You could just call me K or
I know.
Kailash.
I won't do that anymore. But that's like, I've seen like Nitin post like Dr. K every time, and I really like that.
Oh, yeah, that's my nickname. So how a day looks, it has changed drastically over the last few years, and there have been distinct phases. But what has been constant here and maybe a little peculiar in our industry is the regulatory weight. And you wake up, you have certain plans for the day. It could be writing software, could be certain meetings, team meeting to figure out technical, non-technical decisions. Suddenly there could be this regulatory thunderbolt that completely changes your day and the subsequent 30 days. Where you have to pause absolutely everything. Yeah. So that's really a reality of life. And over the last couple of years, there have been crazy number of regulatory changes in the industry, all for the better, but really difficult ones. So days are really unpredictable. You get on with a certain project that you've been working on, and suddenly you have to pause, suspend absolutely everything, and firefight for the next several days. So there's been a lot of that lately.
Right. And on a more personal note, like apart from like everything that's happening in Zerodha and everything, do you get time on a regular basis to sort of tinker around with things? I've seen, of course, a lot of your open source projects. Like, does that happen in pockets of time? Do you try to schedule some time for that?
Scheduling is impossible, but I try to find time regularly, late evenings largely. And mostly, full weekends. So I dedicate a lot of time. I feel if I don't do that, I'll start maybe getting bored of things in general. So for me, finding time for hobby is a necessity. And of course, I enjoy it. It's a win-win. Right. Yes, very regularly.
Right. Another question around that, because very interesting. I've heard a lot of answers from quite a few folks is about like when you are managing a team and been doing it for a while, sort of the importance of writing code. And I've gotten fairly different answers from people as well.
Yeah.
So what is it for you? Like, how much is it just hobby? How much is it do you think you really need to do that to stay abreast of things?
staying abreast of things as a specific goal is something that I don't really think about because I write code on a regular basis anyway.
Right.
So I never had to. I've never been at a point where I think back and think that, oh, I'm maybe losing touch.
Right.
But that said, that's absolutely necessary. Unfortunately, we get to see, especially in our industry, heavily regulated capital markets industry, lots of people who completely lost touch with technology in general, making very technical decisions and often wrong ones. So I think that is very necessary.
Right.
But because I regularly write software, just like all of us in our tech team, it hasn't really been a thought. And why do I write it? I mean, I like it.
Of course.
If I couldn't write software, I wouldn't be, doing what I'm doing.
Yeah. Right. So I have a question around, because we were saying about like regulatory, nightmares that happen, and I think it's fairly discussed in terms of like, say, a business impact, or like sometimes whole fintech companies pivoting because of that.
Yeah.
I would obviously want to, use this opportunity to also delve a little bit into how does it impact like a tech team working on something. For example, I mean, I'm a regular user of Zerodha. That's my trading platform, and I think you have to directly pay for mutual funds now. I think a couple of months back, the regulation came in. It sort of changed because I would just load my funds in one place, stocks and MFs in the same place.
Yeah.
Now I have to do that UPI thing.
Yeah.
So when something like that just suddenly drops, right? And I guess you don't really get a lot of forewarning or something around stuff like that usually, right?
Yeah.
So when something like that drops, like from a tech perspective, like what are your usually next steps? Like maybe well-oiled machine, everything is going on, and suddenly you have to cater to this.
So thankfully, I think one of the things that we cracked early on as a team was handling scenarios like this. If we didn't have a very specific and rather sane framework for handling these regulatory scenarios, I think we would have found it extremely hard to cope with like the huge number of changes that we've seen over the last many years. And if a tech team is constantly pressurized and burdened with making regulatory changes, scrapping systems you've built just because regulations change, if you don't truly internalize and accept that that is the reality of life in the industry, it's very difficult to survive. So thankfully, very, very early on, like almost a decade ago, we kind of realized this. And how we build software, architectural decisions, software decisions, business/product feature decisions, all of that is heavily based on this regulatory framework. Right. So one of the exercises that we do is to try and foresee what could, common sense changes. You know that, it works a certain way, but there's a high probability that 3 years from now, it might change because of regulations. Right. So that foresight, as an exercise, we try to incorporate into all our software decisions. Even writing modules for certain software, you kind of, expect that this might have to be scrapped.
Got it.
So when you do that, and all your decision making in any business idea, any product, any software architecture, when it all incorporates these tiny little things, this form of decision making over time, it kind of puts you in a place where things aren't as hard. Yes, you still have to scrap systems, but you foresaw that anyway. And if you get 80% of that right? I mean, of course, it's super annoying having to delete everything, stop everything, but it's not impossible. We could have been, once you get to a certain scale and risk increases, it would have been extremely risky to just scrap things if things were not built to be scrapped. Okay. So everyone in the team, of course, we joke about it, we meme about it. It's a really hard reality of our lives. But, we have gotten used to it. We expect crazy regulatory changes at any given moment. And thankfully, our systems and processes are 80% always ready to be tweaked and scrapped. So we cope with it. But it's been a long exercise of thinking like that, long time in the making. And we got really lucky that we wired ourselves to accept that.
Makes sense. I have a question about also sort of the product philosophy, especially in Zerodha's context. And I thought of if I ever get somebody to talk to at Zerodha and ask about this, because, for example, every day, like there are hours during the night when some of the functionality in on the app and all stop, right? And it's a philosophical decision, I believe, because somebody can build a product not having those things in place. like how did it come to be? I just really want to have a broader perspective around how did it come to be. Like, why do you have a maintenance time every day? As a UX, it does not affect me. I'm very fine because 2 a.m. at night I'm not trading stocks. But it does happen. So how did it come to be like that?
It's not a philosophical decision. We are forced to have maintenance windows. Not just us, it's basically the norm in the industry.
Okay.
And back in the day, it would be like a 7-hour downtime where all systems go down and lots of stuff happens.
Right.
But today we've brought it down to, let's say, an hour and a half. So why it happens is that this industry is EOD. End of the day, it's
settlements and all.
Correct. Yeah. So this entire industry runs on end of the day settlements. All the real time trades that you do, investments that you do throughout the day, they are real time. That them being real time is kind of an illusion. Yeah. The actual settlement only happens at the end of the day.
Right.
So for us, if we process, let's say 15 million orders in a day, we get 15 million orders worth of data dumps from the exchange. On a volatile day, that can be delayed. So you get data from many different sources, like dozens of massive dumps at the end of the day. Right. You have to crunch everything. You have to do settlements. You have to reconfigure users' accounts, balances, etc. You have to send copies of the results to many different institutions, exchanges, depositories, etc. So that these are really long and complex processes.
Right.
There could be, you could have 6 data dumps that you were waiting for, but the 7th one could be randomly 2 hours late.
Right.
So when these processes are happening, and these are really complex processes, and we've put in humongous amounts of work to bring them down from 20 hours to 8 hours to 4 hours to, let's say, 20 minutes. Just last week we rewrote our entire contract note. You get that PDF at the end of the day process, right?
Yeah.
So that had over time, this is I think the 5th rewrite in the last 7 years.
Okay.
So with this new rewrite, everything is done in 20 minutes, including pushing out, let's say, 1 million emails.
Yeah.
But while these things are happening, the state that you see on your trading platform, that's already stale. But once the new states are computed, new balances, new positions, new results, new everything, they have to be loaded into all these systems. Now, just processing itself could involve, let's say, recomputing 100 billion rows of financial records, historical prices.
Yeah.
So all of this has to happen, and the new states have to be loaded onto the trading platform. So we've made it so that while all of these things are happening, you can still access everything. But that loading process, the sheer volume and size of data that has to be refreshed, the new states, that takes some time.
Right.
And like I said, we've brought that window down to, let's say, an hour. And it's an unfortunate side effect of the nature of end of the day settlements. And if you haven't put in huge amounts of engineering effort, it'll be hours and hours, and you'd be down for, let's say, 8 hours throughout the night. But yeah, it's not a philosophical decision. We are forced to.
Forced by the kind of situation.
And it's an ongoing exercise to bring that window, down as much as possible continuously.
Got it. Makes a lot of sense now. So hearing about, of course, like the process that goes behind, like you're saying, millions of trades happening every day, and then reconciling all of that data. And then this is obviously a question about like how are you achieving all of this with a small team? And that's a question that keeps coming in a lot of places. I've seen, I think once you replied on a Reddit thread about like, we are really just 30 people. I have known a few of people in your team from some time back, so I really know that it is 30 people. For the audience, you're not faking it. But I mean, it's very common for a lot of people in the industry to early stage career, places they have worked. They have probably seen like pretty big tech teams, and maybe the the perspective that it gives a lot of people is that moving around this amount of data, millions of users, is probably just not something we can even achieve with less than 300 engineers or something, right? So I'd love to get your perspectives around, like, of course, at Zerodha, how is it being achieved with so less people? And I love that you had a point there that this should be the norm for a lot of industries as well. So how is it possible? Where are the places where it can be possible?
Firstly, it's very difficult to answer. So the question typically comes top down. How can you do all of this with, let's say, 30 people?
Yes.
But we never set out to do any of this with any number of people. We started out really small and things just happened to be. So it's very important to go from the bottom up when looking at this.
Exactly.
So that so there's no formula for replicating. Tomorrow, let's say you want to build a product like Zerodha, but maybe that something that only happens 1/10 of the scale. Now, could you do that with 5 people or 10 people or 50 people? It's impossible to say or no.
Makes
so
sense.
it's literally a function of the time that we've put in and how the team has come to be. Now, as I said earlier, everyone in the team has a certain way of thinking. That regulatory framework, the framework of risk that we operate in, we really understand.
Right.
Now, if you were constantly burnt out by that, and if you were unable to collaborate, a 30-member team could never build any of this. So the key is that we gel really well with each other. We know how to have fun. We know how to work around our mistakes and laugh about our mistakes and also laugh at our successes. So I think the way the team has evolved over the last 9+ years to this tight-knit gang plays probably the most important role in this outcome. How a 30-member team can build stuff or large-scale stuff. They have to work really, really well with each other. I say that because that comes before technical skills. Now, of course, you need talent and technical skills and expertise to build, systems. You have to sit and write software.
Right.
But if you had a bunch of people who were exceptionally technically skilled, but who couldn't work with each other, especially in an environment like this, heavily regulated, the team would fall apart in no time.
Right.
And so that really is key. How we've stuck to our principles, how we've been grounded since day one. When we had 5,000 users, let's say in 2013 to today, 10+ million users, our attitudes have not changed. We stick together, we collaborate well, we write software, scrap software, rewrite software for the 6th time, we have fun. So, and that also means that the decisions are objective and technical. The moment you have, let's say, tech versus management divide, I think it's impossible. I mean, it doesn't matter if you have 30 people, 40 people, 100 people. I mean, it would be very, very difficult.
Right.
For people to stick together, they have to be in an environment that they are comfortable in, especially, technical folks who are creative. And writing software is not only scientific, it's also a creative endeavor. So again, you'd see that there's no formula here. It's really about people and how people work with each other. And thankfully, again, from the very, very beginning at Zerodha, we haven't had the technical versus management divide, as in, you suddenly get email requirements from the management, no questions asked, and you're supposed to build it. You'd never be able to build quality software with solid philosophies and rationale if that's how it functioned, where someone sent you a requirement, you had no idea why, and you were forced to do it.
Right.
So from the very beginning, we've been conscious of that, and that how the tech team works with non-tech teams, it's been philosophical and it's been very collaborative. Everyone sits down together. So anyone could bring up an idea, propose an idea. People can shoot it down. People are free to shoot ideas down. In fact, probably 95% of all ideas that we proposed have been shot down objectively. And tech and non-tech teams, they know, we have the right culture where people respect such objective decisions.
Right.
So that also has meant that people with deep financial domain knowledge, mostly non-tech folks. Now, today, tech folks also understand lots of, bits, financial bits, but in the early days, it was all the domain knowledge were with the finance folks. Right? But because we were able to work hand in hand, it was possible to bring that deep financial knowledge and the creative endeavor of writing software for finance together. People sat together. All of us have always sat together on the same floor. Just walk up, have a discussion, decision, debate, decide.
Right.
So it's really that. It's really that culture that has enabled us to build whatever we built with just 30 people. And it just happened to be. And of course, skills and the right kind of technical decisions are absolutely necessary. Wrong decisions could be disastrous. So of course, there's that too. We put in humongous amounts of engineering effort and R&D effort.
Right.
But going back to that number, how can such a small team achieve something like this? Absolutely how the team works with each other. It's the culture and philosophies.
Makes sense.
Yeah.
And this is I think a discussion around like what sort of the team size you need to achieve something. And I've had with other folks as well in the past. And I remember actually early days when I used to run a startup, and we had like 3 full-time engineers and a couple of interns. And there was a time I had come to a conference in Bangalore And there were some other edtech founders, and we were talking about, and then they said like, what kind of numbers and all you're doing. And I said that, okay, maybe 1 or 2 million a year we are doing in revenues. We have some, probably free users. We have about, 500,000 of them, some 10-20,000 paid users. They're like, at this scale, how are you running with 4 engineers? And I think, I just asked him the counter question is like, okay, he was doing probably in revenues a little less. I'm like, okay, fine. That's regardless of that. But your systems look very similar to me. There's some video being played. There's some notes people are writing, some questions being solved, MCQs and all. It's an educational system, very similar. You do have like 30 people in the team. Like, why do you have that? I mean, that's also a question, because I did not form a team thinking it will be 4 people. I never needed more than that. And he was saying we had this idea, then we raised some funding, then we thought, okay, to build this, we will need 30 people. So I think the thinking comes from, okay, to build these 10 things, we will need 30 people. And that's the reason he had 30 people rather than probably starting to build it and see where it goes. Maybe that does play a bit of a, I think, because there are enough examples of things built at very big scale, both in terms of features that are there, users that are there, and he had a team of maybe 10 people, 20 people. I mean, WhatsApp was very famous for that. When they got acquired, they had something 19 people or so, and people thought that 1 billion people are working on that app. How is it possible?
That's right.
But I really like that piece of the answer, which is like, you have to sit down with the, tech, non-tech, rather than talking about it in those terms. Like, have somebody with domain expertise and understand what they want, solve that problem together. And it still is like that, you're saying?
Absolutely nothing has changed. We still debate ideas. Sometimes debates go on for days, and ideas are always shot down. Anybody is free to propose an idea. So you have to, if you feel that any idea that you raise will be immediately shot down by the management, I don't think you'll be at your creative best in such an environment. So it's ingrained in the culture that anybody can propose anything, anybody can question anything, and the outcomes have to be objective. We could have a really tight decision, but you write down bullet points on the left side and right side, and whatever weighs slightly more, that's the objective decision, and that has, in hindsight, worked really well for us. And to go back to the anecdote you just shared, I really don't know how that works. I don't know how it's possible to reduce humans who are especially creative, let's say software developers or product folks, how you can reduce them to units and say that this particular piece of software requires 6 human units or 30 human units. I really don't understand how that works, and I've never seen that example play out really well. That approach, play out really well anywhere. So when I think there's this huge component of FOMO there. Let's say you have a product that is becoming bigger, growing, and you receive funding, and you have 3 engineers. People will ask questions. How can you build, whatever you're planning to build with 3 engineers? So you start doubting yourself. And I've seen this quite a bit, even in really young startups who are just maybe a year or two old. They look at the peers and suddenly, that other organization has 50 people. So we have to hire, we need product managers, we need more developers, we need more dedicated designers. So a lot of external factors influence decision making and how to build tech teams, and you end up with massive teams where everyone's a little lost.
There's a little bit of manufactured complexity also in your systems, because Conway's law getting into effect there as well. Absolutely.
Because if you have, let's say, 50 people, they have to do something, right? So you automatically, implicitly, and subconsciously start creating, complicating your architecture, complicating your design to give everyone enough work. So it's a vicious cycle, and it just keeps on getting worse. The more complex it becomes, the more people you need. And beyond a certain number of people, you have to now have other people who manage communication and results and all, and suddenly you get really rigid hierarchies. And you keep on growing. So once you grow, you have to keep on growing. So, and as I said, I've never seen a successful example of someone saying this particular piece of software needs X human units and it working out exactly like that. You can't, it's like you said, it's possible for 20 people to build a WhatsApp that can handle billions of users. It's possible for 2,000 people to build terrible, let's say, net banking applications that don't work.
On that piece, because you talked about that tech and business thing, and then Jacob was here on one of the episodes of Scaler Pod, and he was talking about an anecdote where the VCs had an interview with the CEO and the CTO, and then they were like very impressed that how did both of you have the same answers as to what you want to do in the next 5 years, and then and Jacob say this part which I had it in the teaser of that episode as well, like I absolutely completely totally hate the word the business. I mean the tech is the business, you're building the same thing. Tech
correct.
and business are not separate things. But that's it. This divide, whether it's in minds of people or it's actually there, it does exist in a lot of places, right? And then our audience being like the engineers and the tech people. So my question is, like as an engineer and you're growing, started building things, hacking around, maybe you have joined a company, you're working on things. How do you also sort of gather more perspective about the business? How do you not think of, okay, this is what I was told to build, I don't know how it is going to be used, and that kind of sometimes mindset can percolate if you are in a environment where you have a tech versus business thing. But I think part of the onus is also with the engineers too, because it's a bridge and everybody has to come to the middle. So at a more philosophical level, when somebody is growing as an engineer, how do you go about making sure that you go at least to the center of the bridge for the tech versus business divide?
So I think it's difficult. Honestly, for young engineers, folks who are just starting out, it's very difficult because their worldview hasn't formed. They don't know that they have an opinion. And in many organizations, engineers unfortunately have no voice or opinion. And even in, tech companies.
Right.
So I think the burden, the weight really lies with the management. Culture in an organization, it has to come from top down.
Right.
And no matter how hard engineers try, engineers cannot really create an engineering culture if the management isn't up for it, if they are not in on it. So if to cross a bridge, there has to be a bridge. And it's very difficult in an organization that doesn't really have the right culture of collaboration between tech and non-tech folks. It's very difficult to build that bridge. You have entire managerial frameworks, this whole requirements thing where requirements come in, you're supposed to build it. Let's say in a financial company, financial decisions are made by someone sitting somewhere. There's no rationale. You get a thing saying, oh, add this button, add this report.
PRD.
And you're supposed to just do it. And you're supposed to report to your manager. Now, if there's no culture that has been established by the management themselves, it's impossible for engineers to even attempt to cross the bridge because that bridge has to be built and sustained by the management. If the management is open, people who are willing to contribute will naturally immediately figure out that, oh, it is possible to have a dialogue.
Right.
And it's just that. And in many organizations, unfortunately, where there's this tech versus non-tech divide, there's no dialogue. You get requirements, you build, you don't even know why you're building. It could be wrong. It could weigh negatively on the software architecture. But why would a non-tech management care about software architecture?
Right.
So it has to be top down. The culture has to be established by the management.
Makes sense. Here, and I will play a bit of a devil's advocate here, and it's probably the question is not coming from a perspective that is personal, but say speaking on behalf of let's say a non-tech and a business-oriented founder, let's say. And then we talked about it when we met at Force India as well. It's why should we invest in an engineering first culture? Let's just say somebody says that, okay, I have a bunch of requirements. If the tech team just builds it, I will go ahead and keep building my team ahead. And, I don't need an engineering culture to exist in my team. And fortunately, unfortunately, wherever you put it, but I have seen this sort of dialogue also from people. Right. Right. And then I think that the result of that is like a lot of times people very passionate and very highly motivated engineers get into a company which like from the outside looks like doing great business, but they are like, we just left a year later because we did not feel like having a good engineering culture. So, before coming to, I think, the engineering culture and hacker and open space, I will talk about that as well. But what's the, need even for building an engineering culture, you would say?
I think you touched upon it a little while ago, where this whole tech versus non-tech thing. I think that line is now blurring. So if you remember, there used to be tech-enabled businesses. That used to be a thing.
Correct.
But today, everyone is kind of a tech business. Even companies that run on Excel sheets, are kind of digital tech businesses.
Correct.
And we have this entire category of terms like food tech, travel tech, fintech, whatever. These were all tech-enabled businesses where business was finance. Like Zerodha, for example, Zerodha's primary business is financial services.
Right.
So maybe 8-9 years ago, Zerodha would be looked upon as an organization that offers some technology as a means, merely as a means to provide financial services.
Right.
But today it's completely changed. People see Zerodha as a technology provider, not just a financial services provider.
Right.
So Zerodha has turned into an engineering tech company.
Right.
And so it's a way of looking at that. If you consider that your business just needs tech as one of the small little pieces to run the business of many other pieces, then it's very difficult to have an engineering culture.
Right.
If an organization, if a certain business relies heavily on technology, and even if it's, let's say, financial services or food services or agriculture or whatever, but if engineering and technology are a core proposition of the business, and that requires self-awareness. You can always compartmentalize saying, oh, there's this tech team, they'll build whatever we want, but our business is finance.
My IT team.
Exactly, my IT team. So, but we are financial folks, we'll only do finance, and tech is just a means. So if you look at the business from that perspective, as I mentioned, it's very difficult to establish an engineering culture because it's just one of the necessary evils.
Right.
But as I said, the lines have blurred. Zerodha has become a technology company from a pure financial company. So Zerodha offers technology plus financial services now. And that transformation has played a key role in Zerodha, maybe reinventing or re-establishing itself as a different kind of a player over the last, let's say half decade. Now, if that wasn't the case, maybe Zerodha would be an entirely different kind of company which offered some financial services, but there wasn't scale or growth or whatever in today's terms. So, what is the necessity here? If a certain business, if technology and engineering is core to a certain business, and realizing that it is, or whether it is not, it's really the first big leap.
Makes sense.
So, if it is core, you need to have that becomes the core proposition of your business going forward. That defines your future. And it becomes imperative to have a good technology team. And what exactly is a good technology team? Team with people who are happy doing what they're doing. And I mean content, not super happy maybe, but people who don't hate what they're doing.
Correct.
And again, technology, as it grows, as complexity grows, you can't just have, you can't just get 2 developers in, get them to fix certain things, build new things, chuck them out, get 2 people. It's an ongoing, like a very long-term endeavor, right? The developers who build software, the software enters their mind space and it lives in their heads.
Yeah.
And any knob that you need to tweak the correct way, quickly fix a certain thing or quickly scrap a certain thing, build new features, it's all in their heads.
Yeah, it's just like a completely imagined spaceship kind of thing you have in your head. The live parts. It's some sort of a diagram in your head. Sometimes not even easy to visualize, but
absolutely. So it's not like a commodity where, let's say, you have a mixer grinder that breaks down. You can take it to any mechanic, and because it's a commodity, it's so simple, it's trivial, they can all fix it.
Yeah.
But complex software, it needs people who built that software with deep understanding of its nuances and the million decisions that have been taken over the years to operate it.
Right.
Now, all of those things lives in the minds of engineers and product folks. And if their minds are not happy and they're churning, your engineering team is constantly losing people, new people coming out, of course, that is going to reflect immediately, physically and heavily negatively on your software. You'll have poorly built software. You'll end up with legacy software. Nobody can rewrite legacy software overnight. And all the people who liked it, built it, they've gone because you don't really have an engineering culture. So from maybe a transactional perspective, I'm not a fan of this perspective, but from a purely transactional perspective, selfish perspective for a business, if a business is going to rely on tech, if tech and engineering are going to be core to it, and if they don't cultivate an engineering culture, I mean, it's going to be disastrous for them. We just have to look around us. Massive organizations with unlimited resources, legacy organizations who produce terrible software, who are struggling today.
Right.
And the finance industry, has so many great examples, right? It's all because of that. They refused to accept that technology was core to them. They ended up keeping it as just one of those things that has to be serviced. And there's no tech talent. Why would people want to why would creative people who like creative endeavors want to work in an environment where there's no creativity? It's just a means to, delivering certain kinds of business.
Right.
So absolutely imperative for businesses to do this if they really want to survive.
Yeah.
Yeah.
And that brings me to another question, of course, because we were talking about engineering culture.
Yeah.
Right. What, in your opinion, is a good engineering culture? Also, I'd love to ask, because like if you walk into a tech team and like, what do you expect to see, which would make you say that, okay, this team has great engineering culture? And I say that from perspective of, let's say somebody wants to join some company. How do they decide whether this place has great engineering culture or not?
That's also a tricky one. Culture is very subjective. What culturally works for, let's say, a Zerodha may not work for a different environment.
Fair enough.
So it's highly subjective.
Right.
And that really is the very definition of culture, right? It's an amalgamation of things that change, things have been accumulated, with things which are appropriate for a certain environment.
Right.
So as I said, our culture heavily is built around understanding and accepting the risk in the business. In a non-risky environment, the culture would be completely different. But there are certain principles that are common. Firstly, people have to be chill with each other, irrespective of, people have to be able to make fun of each other without reservations. Nothing is sacrosanct.
Right.
In our team, we have memes about everyone. There are new memes that are made every day. I think there are like 6 or 7 different smileys in very non-flattering poses of my face. And each smiley, denotes a different kind of, situation. Yeah. So there's all of that. And that's just a tiny part of the overall facet, which is, people have to be able to gel well with each other.
Yeah.
That's one thing. And secondly, what I would definitely give heavy weightage to is how people operate, how systems are designed, whether they are from first principles or not. So that is also a part of culture, that thinking that, we need to build a certain thing. It needs to be able to handle, let's say, 1 million users, whatever in that, context. Let's go serverless, or let's pick this cloud. That's very top-down thinking.
Yeah.
So it has to be first principles. What are these 1 million users? Do they even need this certain feature? So should we even bother building it? So it has to always start from the absolute bottom, from first principles. So how a team makes engineering decisions, architectural decisions that are going to be with them for the next decade, that will define their very survival. That comes from first principles thinking. And teams that get together and collaborate on first principles tend to gel well with each other, because, there's no reservations. You're free to shoot down things objectively, saying, oh no, that's not a good idea because, A, B, C, D is wrong. That's only possible when the thinking is from first principle, when it's bottoms up. So it's really that the people should be able to gel well with each other, and technical, business and engineering decisions within that team should be objective and should be from first principles. I think these are kind of 2 hallmarks of good engineering culture. And of course, lots of things change. It's subjective, but these are, largely universal, I think.
Makes sense. I think I definitely relate to that point about breaking down the barriers and the memes and all, because I have at one point of time worked in a much larger company with a hierarchical setup, and there were people in my team much older than me. So to even write a code review and saying that something objectively, it's the review on the code, not on the person, right? I still have to CC the manager because, okay, that person might get offended. And then obviously it's not a great environment to be able to discuss the, technical merits of something if those barriers exist in the first place. For sure. About the, other part as well, right, first principles thinking. Now, and I will actually, of course, like you said, serverless, there are very concrete examples of using, say, NoSQL DBs, and a very interesting blog article that you had written about how you have been scaling Postgres at there, right? And again, I see, because teaching, so I see a lot of people, youngsters, and maybe a little bit of disadvantage being MongoDB is a company, right? And then not to throw shade on them, I mean, there's definitely good use cases of that. But of course, if it gets marketed a lot versus something like using MySQL or Postgres, there's nobody to market that it's an open source project. So ultimately, people develop a habit of say building a lot of projects, and of course, if a particular tool has way too many libraries available, easy to quickly use, people can sort of get into it. And maybe that's also a great way to start. That's fine. But as you grow as an engineer, how do you sort of keep yourself grounded to the first principles? If you could have a word of advice around that.
I think it's about self-awareness and awareness in general.
Yeah.
So somebody who starts out young and let's say their foundation are no SQL DBs. Like you said, nothing wrong with them. They have their use cases. And they've never been able to work with relational databases. How do you even know what you don't know? Now that's a big trap. How do you know that you may be wrong? So it's very difficult. And if you fall into that trap of, let's say always buying into hype, you wouldn't even know that, you're wrong maybe.
Right.
So it's very important to have hands-on experience on a wide variety of engineering, topics and aspects. There's literally no other way. If you've never built a system that uses a relational database, you wouldn't even know. You can't even make that decision. So it's very important to work on as many hands-on projects as possible. But how do you know that you have to work on? Maybe somebody has to, tell.
Yeah.
Maybe somebody has to mentor or guide. But that starting point, just growing that awareness, that's it. Once you have that awareness, then like a billion resources on the internet. You can learn whatever you want. You can build whatever you want. But it's just that starting point. People have to know that what we know may not. There are huge number of things outside of what we know, what are narrow focus.
All the time.
Just that realization and self-awareness, that's what's most critical.
Right.
And that's the starting point. So I don't really have any solutions on how someone can gain that. But like I said, maybe it's accidental. Maybe it's just, people feel that, or maybe they need some hand-holding.
Got it. Around that, I think, and then we talked about like what are the things we would want to talk about here, and you said about like building projects versus products kind of thing, and I really what youngsters say, vibed with that because when I teach some classes and after teachings, let's say concepts of how to build an API, how to build a ORM and all of that. Okay, now go ahead and build a project.
Yeah.
And one of the largest feedbacks, I think probably 70% of people come back and say, I spent a couple of days, could not come up with an idea to build something.
Yeah.
And it sometimes feels very disappointing. Like, hey, you don't really have to come up with an idea that's unique enough or not. Like, how about just build a blogging app or something like that? Build a calculator maybe, but just go ahead and build.
Yeah.
Right. I mean, you have also obviously seen a lot of engineers grow via this, tinkering culture, and you yourself call yourself a tinkerist. So, how much this is important, and why is it important for people to develop this? You would say.
I think it's paramount. It's probably one of the most critical things required to be a good engineer and to be able to learn. What we were just discussing prior. If you don't know what you don't know, how do you even get started?
Yeah.
Right? And building things hands-on, breaking things, getting experience, realizing that, I can do this or I can't do this. It's the single biggest step. Unless you write software hands-on, you can't learn. You can read resources, watch podcasts and videos for years. You'll never be able to produce, decent software. But if you start writing software and produce bad software and improve it, and the very act of writing software and producing bad software, you're automatically improving. That tiny badness, you'll fix it and you would have learned something. So absolutely nothing beats that. And all engineers in the world who are good, they're all self-taught. So it's basically that the act of writing software hands-on is the single biggest requirement to being a good engineer.
Right.
Yeah.
I would like to take an example there. I mean, and I just recently checked out when you had published dns.toys. And I was having a discussion with my friend Saman, and he's a engineer at a big tech company, and he was like, I just loved it because I opened the GitHub repository and I look at the code and I see, okay, no 20 different classes or something. It's just, whatever we need to get it done.
Yeah.
The code inside each function looks very clear and concise, but everything is in one single file. That's fine. I'd like to probably like go a little deeper into like how did that idea come to your mind? Like why playing around with the DNS protocol to like give answers like time zones and everything?
So that the answer to that also answers your previous question. Like you said, sometimes students come up and say, I don't know what to build.
Yeah.
And that's actually a very legitimate problem. It's like a writer's block. You can't come up with unique ideas every day.
Yes.
And sometimes you look for many, many years to, you really have the drive to build something, but you don't know what to build.
Right.
And you can't bring yourself to building, let's say, trivial things. You want something new or unique. But if you look at most hobby projects out there, most FOSS, they're all largely born out of real world problems that people faced or frustration. Like most of my open source projects that I've published, I've stumbled upon them not because I was looking for certain ideas. I had a certain problem. I encountered a problem. I built software to solve that problem. Then I realized, oh, this can be extended and given out to others. You pick any large or small open source software out there, it largely the genesis would have been basically that, people facing a certain problem and then trying to solve that. So, yes, to experiment. I'm sorry, I'm still answering your previous question.
Sure.
That urge to tinker has to be there. But if you go looking for ideas, it's you're probably setting yourself up for disappointment. But when you come across a problem, you have to jump on it and write some software. Tinker.
Yeah.
So dns.toys is a great example for that. I had no vision to write any DNS related things, but I find myself entering random queries into Google every day, unit conversions or whatever. And over a period of time, I've seen that from simple expression matching, 10 GB to 5 MB.
Yeah.
It's a simple string passing thing. I don't know, Google's overly sophisticated technology and maybe machine learning models, sometimes it's difficult to get answers to those straightforward questions also. You get absurd answers, it just goes as a query and the, result doesn't show up.
Yeah.
Specifically with unit conversion or, simple one-line queries to which you really quickly need answers. And, I'd been getting annoyed and I'd been getting frustrated. And that typically is inspiration to, tinker and write something on your own.
Right.
So for unit conversions, I could just write a simple bash script for myself.
Yeah.
But, that wouldn't be as much fun. So then I figured maybe, it could be a service online where I can just quickly get an answer to some of these common queries that I raise every day on the terminal. Now that could be, an HTTP service. You could query it with curl. But curl, it just didn't, it just seemed a little inadequate. And then I randomly had this thought. I don't know what had primed me to DNS. I mean, dig is everywhere. DNS is a protocol. It's a super, super simple protocol. It's universal. It's ancient. It's raw. It's so beautiful, right?
Yeah.
You send a query, you get an answer, UDP, and it's just so good.
Yeah.
Then I thought, why can't I abuse that? It's rawer. It's, more first principles than, let's say, curl.
Correct.
HTTP is a more complex protocol compared to DNS. So I thought, someone would have done it. Someone would have abused DNS. Of course, people abuse DNS for everything.
Yeah.
But then I saw that nobody had abused DNS to get queries to answers. And it makes perfect sense. You send a DNS query. The whole system is around the concepts of sending a question and getting answers.
An answer back, right?
So why not, add this unit conversion thing to that? Then I was like, oh, I also, tend to check weather every day. Bangalore temperature, Bangalore weather. We all of us Google that. And, why not add a weather service? Then I thought, oh, there are these other things. Sometimes, you get a really big number, let's say 10 or 11 digit number. And, I find it hard to mentally parse. I have to count decimals.
Yeah.
So, I Google, numbers to English words or whatever, land on some random website, paste that. So that's also a query that I frequently need answered. So why not add that? So I added a bunch of things and suddenly I had a DNS server that could answer some of these queries and it was universal. Just that its purity, the protocol's purity was very attractive.
Yeah.
So I made it, then of course, if you're typing it every day, it has to have a really short domain name. If I have dnsanswersandquestions.com, that defies the point. So I looked for a domain and found dns.toys. So I can just say bangalore.weather, dig bangalore.weather at dns.toys, and I get the answer.
Yeah.
And that really satisfied, that urge. It scratched my itch.
Yeah.
Of course, turned it into a website, published the repository, and it became an open source project.
Right.
But that's really the genesis of many hobby projects. That one problem that you want solved, it bugs you, annoys you. That itch you want scratched, and just because you're an engineer, when you can do DNS, why do HTTP?
Yeah.
So all of those things put together, hobby project is born.
Right. Actually, that reminds me of something very similar I had done, and this story feels so familiar because it was just before the pandemic time, and I was doing a few consulting with some people who were outside India, like different places.
Yeah.
And we'll meet at 1 p.m. Okay, who's 1 p.m.? Your 1 p.m. My 1 p.m. All of that stuff. Then I used to start figuring out that also the calendar software everybody uses does not necessarily always match. Like Google is still probably 90%, but somebody using Outlook. So you make an event in Outlook, send it to Google. Sometimes because of DST and everything, something happens. And I had gone to a hackathon we had sponsored, and I was there just mentoring some people. And then at night there was nothing to do, and at that time I was learning Vue as a front-end framework, and it just clicked in my mind that hey, just using the routing, the hash parameters and everything. So I found this domain name available, sharetime.in. Send me the sharetime.in /ist/1700 if you write. You can share this URL to anybody. If they open it in their own time zone, it just picks the time zone from the computer and says IST 5 p.m. is 10 a.m. at your time zone.
Nice.
So it's like the URL is very easy to share because share time in, tell the time zone. But I think the beauty is that it was ridiculously simple what I thought that I want. But to implement it, I figured that when I was using some time parsing libraries, so I figured that these 3-letter time zones that we use, like IST and all, that's not the IATA standard. The IATA standard is something like Asia/Kolkata, like that. And the rabbit hole kept digging. Like I figured that, okay, KST is 3 things: Kaliningrad Standard Time, Korea Standard Time. So I figured that sometimes 3 letters need disambiguation. So then I have to add a disambiguation layer in the middle. Like, okay, I build that. Then I figured that Chrome has a bug that they have not updated Asia/Calcutta to Asia/Kolkata yet. I went and write a bug on Chrome's bug tracker, and I found out that there is a thread going on for the last 5 years. And somebody's like, hey, IIT has updated it. When will you guys do it? And like Firefox has done it, Safari has done it, but Chrome is not. And then I found out some message from some cryptocurrency exchange. Somebody wrote that our trades are failing because Asia/Calcutta and Asia/Kolkata in the browser is happening. So I figured, it was very simple. Like I just thought that I will build it in 5 hours or something, and from there got to learn so many things as a result of that. So I think even for example, something like dns.toys, if somebody wants to just clone it and run it on their own, they will learn so much about how to run a DNS server as well in that process. So
that's a great example of rabbit holes. So you tried to scratch that itch of just doing one date conversion. But if you hadn't bothered, you wouldn't have learned so many things. But because you bothered to do it hands-on, you were driven, you learned so many things. This is what engineers need to do. They need to build things with their bare hands. They have to do, even the tiniest of projects. But nothing is really tiny in that sense. Date parsing is a really complex thing. And you went down the rabbit hole. Absolutely.
And it was, I think, like the end of the journey, it was just so fulfilling for me itself. And then I sent it to a bunch of friends. So nowadays, like, when somebody asks me from Singapore or Dubai or somebody, like, when to meet, and I just type them sharetime.in IST, and like, so they read it in that time zone. And then somebody suggested that if I open it from a time zone, can I get a thumbnail preview in WhatsApp itself so that I don't have to open? I'm like, oh, okay.
See, that's great.
I'll build that next.
That's a great idea, right?
So you can just send the URL, the OG tags will work, and you don't even actually have to open the URL then. In piggybacking on all of these different technologies, and
that's a brilliant hack. You should do it if you haven't already.
That's whenever the next weekend I get some time, that's the next thing on my agenda to do that. But I hope if people are hearing, I mean, they whatever the itches they have been having so far, they do scratch some of them and build some of those projects. It'd be really beneficial. But I will take a segue from there too, actually, because you talk about building these things and also open sourcing them. And this is the reason why I have discovered so many of your projects, because they're open source. And then, of course, first of all, thanks to you because you share those instead of just tinkering and keeping them. Now, open source is something, of course, sort of a bit, I would say, abused, misused word also in some places, gets used sometimes as developer relations and branding agendas also some places.
Yeah.
For me, growing up, open source was I figured out how to hack the kernel of a basically reload the kernel of a Android phone.
Yeah.
So then I figured out, okay, Linux kernel is GPL, so I can download, change stuff. And I figured out, okay, phones come with processors with speed limited. You can actually bump them up and you can overclock a phone as well.
Yeah.
And then overclocking desktops or something, people knew it, okay, phones can be overclocked.
Yeah.
And then stuff like that I did. And then I figured, in fact, I opened my first GitHub repository because of that reason. I figured, okay, if it's a GPL code, if you make a modification, it was supposed to publish it.
Yeah.
Just the spirit of that word was so, I think, got very invigorated by that. Hey, that's a nice spirit that this entire community has. You make changes, publish it back.
Yep.
And of course, since then, I've contributed to a lot of open source projects and everything. But from also an org perspective, because there was this FOSS pledge at FOSS United we were talking to about orgs as well. If I talk to individual engineers, a lot of them really appreciate if their org actually supports open source development or supports their engineers to contribute to open source. And I feel that for a lot of engineers, it's a very big motivating factor. Yeah. What do you have to say to orgs or to engineering leaders as well? Like, why should somebody, focus on this? And like you said, sometimes it's very transactional, selfish reasons also exist probably. But, how important is it both for, individuals or also for orgs?
I think it's very important. And a part of, we spoke about building engineering culture and the necessity, right? And I think this is one of the facets of building a solid engineering culture.
Right.
And when I say engineering culture, I also mean hacker culture. So if people aren't in on consuming open source software, and everybody builds everything on, FOSS today.
Yeah.
And if they're not keen on tinkering and, publishing stuff back, that the engineering culture kind of takes a small setback there. So a solid engineering culture, it's about collaboration, and you have to collaborate internally with tech teams and non-tech teams, but it's also about collaborating with others outside. And for what, I don't really have, a quantifiable answer. Like you said, for some organizations, it could be transactional, it could be marketing, it could be a way to attract people to hire them, which is fair. I mean, all of those things exist in the world. They can all coexist. But some organizations do it just for the heck of it, just for the spirit. So there's no right or wrong here. I mean, I prefer a certain perspective, but many organizations do it for selfish reasons. Like I said, it's fair. But it's important because it enables all of these things.
Right.
It makes engineers better engineers also, because when you write something for yourself, how you write that, how you think, how you architect software, it's very different from when you have to build something for others. When you write software for other parties, and open source software, millions of people could use it, people you've never seen, people in completely different geographies, different cultures, different perspectives, different requirements, they'll take your software and use it in ways that you never ever imagined.
Exactly.
So when you write something for others, for unknown users, it's a whole different framework. You're writing it with as many holes closed as possible, as many edge cases addressed as possible, as clean an architecture as possible. And that just makes you a better engineer anyway. And you'll start applying those principles in your internal projects also, thinking that, I'm not writing this for myself for today, I'm writing it for whoever it could be tomorrow. So there are many benefits to that. And, building a culture, transactional, selfish reasons, just practicing, being able to write better software by writing it for others. And of course, you consume all this open source, giving back. And when people derive utility from the software that you publish, it's immense amounts of goodwill as well. That may not translate to money, but it's if you care about it, it's a lot of satisfaction.
Right.
So many of these reasons, like a number of reasons why it should be done.
Right. I feel it's a little unfortunate in India. It happens way less, I feel, because Zerodha definitely does. Razorpay I have seen. Flipkart, there was a time I used to follow. There's a lot of great stuff they used to open source. But it's not something very, very prevalent. Versus, I know a lot of my friends who have probably, moved out of India and in US and all. A lot of times they end up picking up a job because they found some open source project which they needed for some of their own use. They found, oh, this is made by this org, and they're like, I would love to work at a place which has made something like this.
Yeah.
So this is something that I think definitely should improve in our tech culture here in India, I guess.
Absolutely. It is so disproportionate, it's actually shocking. We have, I know, dozens, 100, unicorns, massive tech companies, unlimited resources, tech companies that build, cutting edge technology. Most of them are in Bangalore. But if you look at the number of open source projects that come out of India, it is so disproportionately small. It's practically non-existent compared to this massive, wave of digitization at every level, at the governmental level, at the industry level, young companies, old companies, cutting edge startups that are expanding all across the world. All of these things have come out of India, but the same industry which uses open source software to build all of this, build all the valuations, build all their products, produces so little to the point that it's non-existent. I think it's a cultural issue. It goes back to exactly what we've been discussing. If you have a tech versus management divide, if you have a management that isn't keen on engineering culture, there'll be no encouragement to get people to, open source things. And if you pick, dozens of really big, popular, large tech startups here, and if you look at the management, I think it'd be a sad realization that many of them are not really engineers. Although these are all tech companies, they're all led by people who don't really care about engineering. Right. If you don't care about engineering, why would you care about encouraging your developers or tech teams to produce software to give out to others? What do you gain from that, right? Nothing. Right. So it's a sad cultural issue. And again, before this started, we had a brief chat about FOSS events in Bangalore, like how early 2000s saw a large number of thriving open source communities all across India. There was the OpenStreetMap movement was big. The Wikipedia movement was big. Lots of students got participated and entered FOSS via Wikipedia.
Yeah.
There were lots of FOSS events, hacker events. But over the last 10 years, now India has become this techno innovation business hub. But FOSS-related events have kind of almost vanished. All the communities, they've vanished. And many of these events today happen under very corporate umbrellas. There are tech events, not exactly open source events or communities.
Yeah.
Today, when we have unlimited resources, when the private tech industry has unlimited resources to conduct and encourage such events and groups and organizations, we don't really see anything. So I think it's all very cultural. From engineering/hacking/tech, we've gone to like a techno business realm altogether, which is fair, but you need to have both.
Yeah, so of course.
Maybe it'll come back around. We'll see.
Even techno business realm, I mean, it's fairly common to hear, probably from my perspective, because there are people hiring engineers from SCALER, so we get to hear from exactly the people who are hiring.
Yeah,
we're getting very difficult to hire good engineers. So it's a term I keep seeing being thrown around. But I figure that if you don't create the atmosphere where whatever is your definition of a good engineer thrives, then you will have this complaint for sure, right?
Absolutely. And it's the ethical responsibility of tech companies who benefit from all open source software and tech and good engineers who've come out from these ecosystems to contribute back and help produce a thriving engineering culture everywhere.
Right. Also, from a and this is maybe imagine a question coming from somebody fairly young, like early 20s or something, getting into tech, and I keep getting this question myself. And then I try to answer the best I can, but would love to get an answer from you for those people as well. There are people who have maybe just heard about a little bit, okay, there's this guy, very good engineer, he started his career with open source, stuff like that. People hear such stories. And then people ask like, okay, how do I get into open source? And then obviously that's a very vague question in that sense.
Yeah.
But nevertheless, like you said, there's a big chasm of not knowing what you don't know.
Yeah.
If somebody's even interested up to that point.
Yeah.
Right. Yeah. I mean, I heard from some people that it's great to participate in some open source communities or contribute to some open source projects or build some of my own projects. I heard from somewhere, could be good for me.
Yeah.
And then sometimes just at that point, there's a question like, how do I go about doing it? What would be your answer to somebody very young, just getting started? What should be their motivations? And then, probably I would not ask what should be their motivations. I think the motivation is fairly there. They want to get into it. They just want to know how they should go about doing it.
This is a question that I see very frequently.
Yes.
I want to get into open source. How do I?
Yes.
I think it's difficult, to be very honest. If you want to start contributing to large existing projects, you need a certain level of expertise and understanding, and
Some of those
deep
code bases are
understanding.
very overwhelming.
Absolutely. And for projects that are run, for large projects maintained by skilled teams of people, why would they accept contributions which are not meaningful?
Yeah.
So this whole question of how do I contribute an existing project is a slightly problematic one.
True.
Especially for beginners.
True.
So to get started with open source, you have to get started with hacking and engineering. You have to become a software developer first. You don't have to have 10 years of industry experience, but you have to have hands-on experience of having built something.
Right.
So before you get into open source, get into engineering. You have to write software. Write a date-time calculator, or play around with the DNS server, build something.
Yeah.
And when that happens, the doorways automatically open up. For instance, like that example with your toy project was great. You just wanted date-time conversion, but that you picked a date library. You went into a rabbit hole of issues. Maybe one of those issues that you found in a date library, you'd know how to fix, and you could send a fix there.
Yeah.
But if you start out by saying, I want to contribute open source, where do I start? Nothing will happen. You can never start.
Exactly.
So you have to start by becoming a software engineer, build your own projects, hands-on projects. And in that process, you'll start using other software libraries and whatnot. And that will open up pathways.
Right.
So that is, I think, the only way to really do meaningful open source contributions. It has to come to you when you're working on those things hands-on, building your own projects or building stuff at work or whatever. But if you just wait there saying, how do I get started? I need to get started. Nothing will happen. So you have to get started by writing software.
Makes sense. That's definitely a great place. Now, I'll probably go deeper into that particular rabbit hole of how to get started to open source too. Then there's a next set of questions which come from people about also how to go about their engineering careers. And we discussed it back when we met, about that. Sadly, sometimes a lot of it is FOMO driven. Maybe the FOMO can give you a good place to start, but if that's what keeps on driving you, might not end up with the correct direction and all. I would like to also probably predicate that with one background. And I remember a long time back, I saw an interview with Linus Torvalds. And he was saying that, and there was a lot of outrage in India about that interview because he just said something which people perceive to be anti-India. But he said that, what I see is, I don't see somebody from India creating something like Linux kernel. And the interviewer pressed on, like, why? And he said that, when I was starting with, Minix and, hacking around with BSD, and I created the Linux kernel, I was not thinking like how I will get a job next. I had just, I was in Finland, I had completed my university degree, and I did not need a job right now. I think the Finnish government pays some bursary amount for a couple of years till you figure out a job and you can. So it's like I was just hacking around. There were some old Solaris boxes lying somewhere, plugging some hard disks and seeing if I can write a better driver for that. And all of that stuff I was doing. And out of that, Linux got born, and I did not set out to build something like Linux out there. And then he talked about how I was not finding a good version control system, so I wrote Git and all of that. I have come to India a bunch of times, and I've met Indian engineers, and somebody right out of college is thinking so hard about jobs, and that's a background that we should also keep in mind, I believe. Because we are not a very rich country, we are a poor country, and a lot of people have a lot of responsibilities, probably education loans, and they're getting out of it. Despite given that background, how do you say people should go about like the early phases of their careers? What kind of things they should learn, and what can be good motivations to sort of keep learning more things?
See, it's very difficult to talk about motivation. I mean, it has to come from within. And
correct.
When it comes, why it comes, when the spark happens to be a hacker or, do things for the joy of it, it's very difficult. And like you rightly said, we can't compare our economic conditions, especially over the last few decades, with, say, our Western counterparts. There, when you have great social security, it's possible to think like a hacker. I'm not going to think about a career. I'm not going to think about a job. I'll just hack around because you have great social security. But again, like you rightly said, we don't really have that sort of social security here. People have big economic obligations.
Right.
And to meet those obligations, you have to find a job. Right after college, you're mostly forced to find a job.
Yes.
So it becomes really difficult. Unfortunately, because of that, the ecosystem, the environment here isn't really ripe for hacking. And once you, and we've talked about culture or the lack of, a lack thereof, engineering culture in our industry. Even the new age tech industry, which is flush with cash, even that lacks it. Now, when a young student who has economic obligations to meet enters the industry, and if it's a large, big IT industry, it's they get churned there. There's no engineering. It's just services. It's drone work, unfortunately. Or if, let's say, they entered this new tech industry, which has all the resources, well-paid jobs and all of that, but there's no engineering culture.
Too chaotic there, I guess.
Yeah. Exactly. I mean, if without that culture, right, what sparks this whole idea of motivation? There has to be something, right? It has to be people around you. It has to be the environment you are in. It could be it could be a community. It could be a conversation that you have about hacking with someone. It could be anything that sparks, and that spark has to sustain. Now, the probability of that spark occurring is low because of whatever reasons, we don't really have that engineering/hacker culture. Not in the old industry, ironically, not in the new industry, and not really in our educational establishments, most of them as well. Again, for whatever reasons, large sections of educational establishments are geared towards producing graduates who get into this, this churn.
Yeah.
I mean, there are strong socio-political, cultural reasons for that, economic reasons for that. We can't really blame anyone, but that's the reality.
Right.
So when you come out, when you go into any of these paths, when you take any of these paths, the probability of you getting started, you getting that motivation, you getting that spark to do something, try something, have fun, is low. Yeah. It happens, but it is really low. So it's a problem. It's something I think about all the time. When people especially say our colleges don't produce, fast hackers. Why is that? So many, millions of people who finish engineering degrees, but how many open source projects come out of India, right? So these are all really complex reasons, and it's a bit of a lose-lose where,
Sadly,
in all these areas and paths. So it's just really hard. Right. Now, how do you get motivation? I don't really have an answer. I think that spark has to come from somewhere. So the people who have the ability to, let's say, set up ecosystems or help create environments that flourish, like strong engineering cultures, people who have the resources to do that, I think it's their ethical responsibility. Like I said, right? Many of these big startups that we have who are flush with cash, who use tons of open source software, what they could do to give back to society. And this is not about producing projects for GitHub.
Correct.
The second, third, nth order effects of this engineering culture could be huge for a country like India, right? If we had more and more people creating software, public goods for other people to use just because they like using it, it's extremely valuable for humanity in general, right?
Yeah.
But you can't tell anyone to be motivated or to create software. It has to come from within. So what we can do is people with access to resources, whatever, we have to consider it our ethical responsibility and create environments like that.
Right.
So I didn't answer your question, but I don't really have an answer.
Right.
These are my
I think thoughts. Maybe I would probably use this opportunity to also push a very personal pain point, especially with like at Scaler exactly the stuff that I have personally faced is, and then again this is probably like a bit of a complaint against, I would say, tech companies who also say that it's difficult to hire. We have often gone to tech companies who are interested in hiring people, and I've said that, okay, see, sometimes obviously like very big companies, they have a certain process. It's a pipeline kind of a thing. Solve some lead code problems, system design, interview, and go. But there are people where it's a smaller company, it's a very product focused, engineers, the CTO open to talk. And we have sat down and they said that we want exactly somebody like this, somebody, let's say, who understands operational logistics, who can, build an end-to-end project in, let's say, Node.js. They have a very specific idea of what they're looking for in mind rather than a broad brush good engineer. And even despite that, what I have faced a lot is that I say that, okay, if you have a very specific requirement like this in mind, how about I suggest you something that, you spend a little bit of engineering hours with us to help us build a project. And we roll out that project, and some of the learners at Scaler, they will build it. and your engineers can spend maybe a couple of hours a week just code review what they have done, mentor with that project, and you do it for a month. Some of the people whom you really love who have built that project, you can hire them. You can't get a better signal than that. And I'm going to be doing most of the heavy lifting for you, right? I am really interested in letting some of my students build some projects, and even they would be very invigorated because it's like a big unicorn company and their engineer is mentoring you in a project. And even there, then the pushback is like, okay, we won't have time to spend on this, or maybe we don't have the bandwidth to do something like this. And there I feel, that's probably the point where I would say that that's my complaint here, is that if you have a very specific kind of engineer you're looking to hire, and you want all of the signals, and I'm creating you a canvas where you can actually get those signals from people. It's sad if you don't want to even spend that amount of time. This is not like publish an open source project with license and everything. Even maybe this is even less effort than that. I'm just saying, couple of your senior engineers spend 2 weeks, 3 hours a week, right? And then mentor a project, right? And I personally have seen that work so well. So when I was at Zomato, and I think the two of the best hires in my team I did was via something we call trial week, where somebody would come in a week work with us, right? Only thing is, it's a little discriminatory to people who can't take out such a time. Maybe they're working somewhere and they can't come and spend a week. So fairly junior people you can hire like that. You're hiring somebody senior who has a family, who are established in a certain city. You can't say that, just leave your job and 1 week come and hack with us, and then we will hire you. But the two people I hired, they were the strongest hires in the team. For sure, because you have worked with them for a week. It's obviously better than taking an interview. But I think, if companies do actually put out that effort, it's really compounds a lot back to them. And then with, like you're saying, the resources that they have, it's just, probably like a sincere appeal that they do that. Because I also have anecdotes, like when I ran my first company as a startup, and we used to do everything open source. As telling you that time, like, we did not think that we were a startup because we were just teaching people. Then edtech as a word was not so common back then. And it was I did not believe that the software we were writing was anything unique. Just playing video, writing some commands. It's very run of the mill, right? Off the shelf type of software, but off the shelf did not work. There were some LMS systems that did not work. So we thought, okay, we'll write our own software for that. But I thought, okay, let's make it open source. One of the best outcomes of that was people who joined our tech team were all people who were students in that place. They figured that the tools that we're using to learn not adequate. I will add some code, and I'm like, hey, why don't you come on board and join us? There was this whole entire online ID, like complete something like a VS Code kind of an environment, and that was entirely written by people who were not employees of the company. It's just people figured that, okay, I can tinker with it, and then I can add to that. So I think that value sometimes also, that message is also with the leaders is also, they don't see it, because I've worked with some European companies where I see that they very much understand that second, third, fourth order effects also, and they have seen those benefits. But maybe, I don't know, we as a ecosystem have not yet seen those fruits of the second, third order, and that could be a reason.
Absolutely. See, it's a lot of us is really altruism, right? Some of the most valuable projects in the world that all of us, billions of people use, are made by a handful of people who make it because they like making it. They struggle to make a living with, with a difficult job, and at the same time they contribute their personal time and effort into a FOSS project that they give out to the entire world for free. And if you look at the larger FOSS ecosystem, most projects would be like that. Why do people do it, right? It's, of course, you do it for fun, you do it for satisfaction, but there's also this aspect of, maybe it's a very touchy word, altruism. So I think like the examples you mentioned, right? They're great. So companies want to hire the best engineers. They want to use the best open source projects available from across the world to build their companies.
Right.
Why can't they give back? How can it just be always consumption? We'll pick up the best software. We'll hire the best engineers. We will, we'll throw out ridiculous offers to attract the best talent.
Right.
But where does this best talent come from? You can't become a great engineer by reading books or watching videos. You have to be involved in all of these things. You have to work on lots of projects. You have to collaborate with others. You have to be familiar with FOSS projects. You have to produce FOSS projects. For this, whatever we've been discussing, you need a thriving ecosystem here of engineering culture, of appreciation for engineering.
Yes.
So you can't expect to find great engineers all the time in unlimited supply if you don't contribute back, whatever it is, to create an ecosystem that produces such engineers, right? So it's very short-sighted and blind of organizations here to just expect to be able to always find great engineers while never doing anything to produce great engineers.
Right.
And why do you produce great engineers? It's like I said, it's also it's ethical responsibility. Even if you can't foresee the outcome, we publish this open source project, or let's say we run this community event, or do whatever, we fund some open source projects. What do we get back? Maybe nothing. But at some point, all of these things, all of these things have to happen on a large scale for good outcomes to happen for everyone. But if you transactionally look for very specific outcomes, I sponsor this conference, I want this back. That doesn't scale. And then you can't complain that there are no great engineers here, because nobody's doing anything to produce great engineers. And how do you produce great engineers? All of these things without looking for specific outcomes.
Yeah. I have like a handful of friends from my college days who have fairly, probably I would say, burnt themselves out of the India ecosystem at this point because of this. Because these were people with whom I would go like almost 1 or 2 hackathons every month. They would love doing stuff like that, working on open source project, participate in Google Summer of Code. And I had a group of some 10, 15 people, and a lot of those people are now at a point where, there isn't an, Indian tech startup which is even pitching that, hey, come here because we hack on cool stuff.
Yeah.
Nobody's even doing that pitch. And I want that pitch. And a lot of those people have eventually moved out, especially they find some places, especially, Amsterdam, France, those kind of places. There are a lot of companies who are actually literally pitching that. Forget how many users we have, or how many requests per second we process, all of that. Just come because we build cool stuff. We go to hackathons, we participate in conferences, we build open source projects, and then come because of that. It's a very direct pitch. And I think people should actually look up on that and see that it's a pitch that actually works with a lot of engineers who really want actually that out of the work. They just want to have fun. They want to hack on stuff. And you're probably missing out on great engineers who are looking for that if you don't create an environment where you let them do that in the first place. And then of course there are the second, third order effects around that as well. I'd like to take a segue into something else, which is we were earlier talking about, as like the tech versus business thing. You were saying that the tech is the product, and it's from going from tech enabled to actually being tech products happening across a lot of these verticals. What sort of going ahead, looking at the industry, probably wider industry, but also finance, something that you have been doing for so many years, that what does like sort of more emerging pieces of tech look like? Because I have obviously read that Nitin had shared about AI in finance thing, but nevertheless, I don't there are a lot of new things coming up. AI, blockchain, all of that. But apart from the hype words, what sort of the future of tech in this domain looks like going ahead?
Difficult to answer. But I think, big revolutions happening in AI, many different kinds of ML and AI technologies becoming commoditized, etc., will accelerate better technology for sure. But AI won't just come and change finance. Or, suddenly there's this thing called blockchain and it'll completely revolutionize a certain thing. It doesn't work like that. These are all building blocks.
Exactly.
Somebody has to come, take the right building blocks, find the right problems to solve, and use these building blocks meaningfully to solve these things. If you look at, let's say Kite, our investment platform, you look at Kite in 2022 and you look at trading platforms that were available on the desktop. They weren't really mobile platforms. Or forget mobile app, our web app versus web apps that were available 10 years ago. Fundamentally, nothing really has changed. Fundamentally. As in, you log in, you see stuff, you press a button, it's all on a web page, you can place orders, etc. But these systems are light years apart. And lots of, like a million subtle things have changed It's still a web app. It uses JavaScript. It was a web app. It used to use JavaScript. What has changed is sensibilities have changed.
Right.
These, not just us. Many newer companies care about user experience, and just by focusing on good user experience, we've had a large number of products emerge, high quality products that you can't even compare with what existed 10 years ago. But technologically, they may be the same thing. Maybe it's just, slightly better web frameworks, slightly better mobile frameworks. So I think drastic changes is going to come like this. Lots of little pieces coming together to produce better and better quality software.
Right.
I don't think there'll be anything, let's say in finance tomorrow, that will completely change how people, interact with finance.
Like a mic drop kind of a thing.
Exactly.
That does not happen in tech.
That doesn't. That's very rare. That happens very rarely. And if you look at how people treat investing online today, there are 18-year-olds signing up versus how it happened 10 years ago. Only 60 plus people in the 50s and 60s traded. It's completely changed.
Yeah.
But did that happen overnight? No, it happened over a decade, maybe accelerated over the last 4 or 5 years. So any sort of change is going to be like that. Maybe people will start using machine learning technologies to solve very specific problems, and there'll be a big UX boost. Then someone will come build on top of that.
Right.
So 5 years from now, when we look back, maybe things will look drastically different.
Right.
But I don't think there'll be one discerning point where one technology comes and revolutionizes everything. Let's say in finance.
Yeah.
And specifically with finance, at the end of the day, it's about money. If it's about people making money, losing money. Software, technology, UX, etc. are secondary. An ugly app that makes people money, people will use that, rather than a beautiful app that loses them money.
Correct.
So at the end of the day, with finance specifically, it's basically that. All these incremental things help people, improve on certain things, but nothing major.
Yeah.
But if you look at certain other industries, for example, things like GPT-3, etc., right? The possibilities are very exciting. And maybe some of these technologies will completely disrupt how people produce art. There are all these, stable diffusion. There was an open source release just 2 days ago. Now people can run stable diffusion on a commodity GPU and produce insane art.
Correct.
Programmatically.
Correct.
Sorry, with a simple English prompt.
Yeah.
Now that could completely redefine how stock images work.
Yeah, I mean, designing YouTube thumbnails, for example, is something that, if you're doing it remotely with the designer, and you have a vision in your mind and you just try to communicate that to the designer, and then they come back with it and those iterations. Sometimes I feel like even if it does not replace the entire cycle, I can just put a prompt into something like DALL-E or Stable Diffusion. Get a rough image and send that to the designer that, I want something like this.
Absolutely.
Changes the game completely.
Completely. And millions of blogs will suddenly have, very contextual, great-looking images.
Right.
So once in a while, technologies like that come along and disrupt things overnight.
Right.
But that is very rare. If you look at the last 10 years, you can think of 2 or 3 of these technologies that completely changed the game practically overnight for a lot of industries.
But you can't aim for those because they are black swan event kind of things.
Exactly. So drastic overnight changes happen very rarely, but mega changes over a few years and decades happen all the time, but you can't pinpoint when that happened. It's, it's really complex.
Right. I did have a few questions about, and I just remembered that, is about some of the folks who got to know that you would be coming, about, Zerodha's tech stack as well, by the way.
Yeah.
And that's something a lot of people are interested in knowing. So I'd start from, of course, the first is something which is more closer to me is like I have been a mobile engineer for a long time. Zerodha was probably the first one to take a bet on Flutter. It wasn't so popular back then. It was very alpha beta level. So what made you do that? And then versus I think you had a React Native app also long back originally. So how was that played out? And I would say probably zooming out, like you were saying, first principle level thinking. So what are the probably ingredients that went into taking a decision like that, and how is that played out?
Yeah, it was a big decision. It was a hugely risky decision, and Flutter was pre-alpha. And I don't think anybody was using Flutter for anything except for the Flutter team's own demo apps. There was nothing else. And Ajin from the tech team has written a great blog post describing this entire journey chronically
I read it,
on why we made that decision. So just to quickly summarize the gist of it, we had a native Android app our trading platform. And for iOS, it was written in React Native.
Right.
And of course, maintaining two different code bases for two different platforms is a huge pain.
Right.
And this was a time when we were making a lot of changes, not just regulatory changes, we were evolving as a product. So
Right.
new things had to be built constantly. And building two things in two different ways, in two stacks and two code bases, and releasing them at the same time, of course, it's problematic.
Correct.
So it was very clear to us that we wanted a unified platform where at least 80-90% effort would be the same. And React Native was something that we bet on, but it flopped. It wasn't mature. This was back in 2017-18.
Right.
It wasn't mature enough. We had way too many difficulties. There were performance issues, and we stumbled upon Flutter, which looked very promising.
Right.
Its architecture was promising. It's the language of choice, Dart, which was a new invention, that had certain benefits. The way it was architected looked promising.
Yeah, like drawing the pixels directly is. Correct. I have always loved that because you take the Unity and all game engine philosophy to an app.
Yeah.
Because when you think of cross-platform, then the biggest problem is like how Android draws things and how iOS draws things is different.
Yeah.
If you keep fighting it, like React Native is actually fighting it.
Yeah.
You will keep on fighting it, and the platforms will keep on innovating, and you will have to keep on fighting it.
Yep.
Versus if you really want true cross-platform, I think just circumventing that and just draw the pixels directly to the screen.
Yeah.
It does come at a little bit of, I think, graphic rendering cost for sure versus like native Android. But I really like that philosophy when it originally came out.
Yeah. And I think for mobile, it was workable because mobile applications did tend to look very different.
Yeah.
The problem with cross-platform UI, GUI libraries is that they are impossibly hard to pull off, which is why even today we don't really have great cross-platform UI frameworks for Windows, Linux, and Mac. You have to keep fighting OS APIs. It's extremely difficult to unify.
Yeah.
And the thing about direct painting is that for operating system apps, they use OS widgets, lots of elements, right?
Yeah.
And if you don't nail that pixel by pixel, it feels like an alien app.
Yeah.
On mobile phones, people are used to, seeing different kinds of UI. So it was possible to get away with that here. But the same attempt on desktop is really problematic. So an app that looks like a Windows app on a Mac will completely throw people off.
Correct.
So that's the downside of painting. You have to reinvent, native look and feel and controls and nuances from scratch, which is an impossible project when it comes to desktop systems. But for mobile, yes, absolutely. Like you said, it allowed Flutter to bypass, all these quirks.
Yeah.
So we were greatly smitten by Flutter as a technical framework. We liked how it was architected. But now the decision, just because something looks great technically doesn't mean, you can bet your entire future on it. There are many other considerations. We didn't know Dart. So there were many objective decisions that went into it. Is Dart viable? Can we learn Dart? Is it possible? So we answered that question by experimenting. We built a prototype in like 2 weeks of what we wanted to do.
Right.
List views with, real-time market ticks were a problem. It has to render at 60 FPS.
Yeah.
So we built a, 50-100 item list view in Flutter. So we saw that the list view had a bunch of issues, but, it was open source. We were confident that we could fix it. While Flutter was evolving as an alpha program, these big issues that it had at that point, with a hands-on experience of 2 weeks and technical dissection and looking at how it was built architecture, we built confidence enough to realize that, these issues, let them be there. We can work around them.
Right.
Then the final question is, can you bet your technology on this? What are the factors that would allow you to bet your future on this technology? What if, Google kills the project? What if there's no community around it? What if people don't write libraries for it? So that was a very difficult but objective decision again for us, where we realized that the pain that we were facing with a native code base plus React Native was far greater than, let's say, Google killing off this in 3 years. We figured if we could just port this and run it for 3-4 years, because it was open source, by patching it ourselves, maintaining it ourselves, and all the bells and whistles it had suited our requirement, it would still be worth it.
Right.
So that trade-off, despite all these issues, despite all these risks, it would still be worth it. That's the most critical, pivotal decision point.
Yeah.
And we're like, fine, let Flutter be killed if it's getting killed. It would still be worth it for 3-4 years.
Right.
So to arrive at that decision, of course, we had to make, actual hands-on. We had to build a prototype. I mean, we couldn't just look at the GitHub issue and decide. So it was a very careful, objective, technical, first principles decision-making process that started out as a very technical thing, then went on to a tangent of business and organization, like the risk.
Right.
And we made the decision, and it turned out to be a great decision.
Right. I mean, that's fair enough. And I think I have seen places where, like you're saying, if Google abandons it, kind of a thing. So at Target, there used to be a library that we were using for 3D rendering some models so that you can virtually try out some products that you want to buy and stuff like that. And it had two versions, I think. One where you would actually use direct 3D models. Another one was where you could just sketch it out in some pseudocode kind of language and some 3D models. Yeah. Google stopped supporting, like they abandoned the sketch thing. And Target started maintaining it because it was very important for us to actually use it. Yeah. And the decision to actually buy into that was right from day one, that if Google does not actually maintain it, we can do it because we understand the system, how it works, and it's important for us. And there isn't any better solution for us right now. So
that's a great trade-off. You even have to visualize the worst case outcome when picking a technology. And once you know that objectively we can handle the worst case outcome if it were to come, then you're kind of safe. And 90% of such decisions don't turn out to be disastrous.
The worst case, like you have cover for that.
Exactly.
Makes sense. So coming from that mobile architecture to also to web systems in the backend, and then I've heard from folks in your team as well, some friends who I have, is it's fairly simplistic compared to what I see today. Is especially when I'm teaching, is that a lot of people, like once they get started with actually building things, there's a lot of questions around, okay, what you're teaching me, will you teach me how to build in microservices, or will you teach me how to deploy serverless to the cloud or something like that? And while occasionally it can be exasperating, because I'm like, let's start building something. We will figure out, we can separate it into services, we can, serverless or, VPS, how we will deploy it. Let's see, we'll go there. But I think the hype of a lot of those terms have permeated. And if it was only hype, it was one thing, but there are people who are actually building stuff which is getting influenced by that hype today. It's something I feel. I recently wrote a very long Twitter thread about, like, probably very contrary and unpopular Twitter opinions, but there are a lot of folks like Amod and then Ajay, they retweeted, they said that these are probably good points. It's sad that it's unpopular, but then I would like to delve a little bit into how's your tech stack look like, and how do you go about doing deployments. I see it's very unconventional that you roll a lot of things in-house versus using a lot of cloud-based services. So if you could run me through a little bit of that.
So the tech stack has evolved greatly over the last decade, but not really in principle. In the physical manifestations, we've changed databases, we've changed programming languages, but the approach has always been first principle. So when we really started out, we didn't really have a roadmap. When we started out almost a decade back, we didn't have a roadmap to build a trading platform. We wanted to build technology to solve problems inside Zerodha first. So in the very beginning, it was Python scripts that cut down, let's say, 1 hour of manual CSV processing to, let's say, 2 seconds. Right. And it was mind-blowing for the people there.
Right.
And so that's really the origin. The right tool to solve a physical problem, the right job. That's how we started out. We didn't say we need full stack, we need a trading platform, we need UIs, nothing.
Right.
So then we started, solving slightly bigger problems. Back then, it was just me. When we started Zerodha Tech, it was just me. And I was sitting there, I'd go sit with non-tech folks, find their problems, write Python scripts to automate. And at some point, I had too many, people got the taste of automation. It wasn't even tech, it was automation. And they're like, oh, can you automate this? Can you automate that? And that's how we were very slowly becoming a, digital business, from pure offline paper stuff to slightly more digital.
From a brokerage firm to a trading platform.
Exactly. That transition was slow and very organic. Support system was a single Gmail inbox that let's say 20 people logged into. That obviously doesn't work. Then we brought in, I installed OS tickets, an open source ticketing system. So all these tiny pieces. At some point, I realized I was getting way too many things that I could handle. It's time to build a tech team. So after several months after starting Zerodha Technology as an organization with a roadmap to build technology in finance, we hired our first engineer. So only when I exhausted my capacity, then the two of us started doing whatever I was doing. And at some point we were like, oh, we need more hands. Then the third person, then the fourth person. So the team grew very, very organically, and as did the stack.
Right.
So in the very beginning, as I said, it was Python because I was okay writing Python. I could write decent Python, and it was Python automation stuff. Then we started to store database. Sorry, we had to store transactional data at some point. Suddenly there was Postgres because I'd always known Postgres. I'd worked with Postgres. Certain things for whatever reason had to be MySQL databases. I knew that also, so we used that. OS Tickets, for example, uses MySQL.
Yeah.
And OS Tickets is a PHP system.
Yeah, all those old software.
Yeah, correct.
WordPress era software.
Exactly, WordPress era. And that required some tweaking. So suddenly PHP was also a small part of the stack. So we picked the right tools for the right job. For for support ticketing, it was this. It was appropriate. For something else, it was that. It was appropriate. At some point, after lots of digitization, after lots of backend dashboards and whatnot, with let's say Django, because we are already using Python, at some point we suddenly had an end user product on our roadmap. So that was built in Python. We used Redis for caching because everyone was using Redis for caching. It was memcached or Redis at that point.
Yeah.
And Redis was slowly picking up, gaining popularity. So we built a Django-based system. I think there was also this library framework called CherryPy, which was simpler than Django.
Okay.
But it was a Python stack. So our apps grew, features grew, complexities grew, issues grew, databases grew, data size grew. Lots of end-of-the-day number crunching that was based on proprietary, really bad Windows software, which was norm in the industry. We started rewriting in Python in-house. So suddenly this data backend Python-based stack happened. But Python, Redis, and Postgres were really the big pieces. And 2017 is when, by then we had, then of course the mobile app happened.
Yeah.
Right after we built Kite, the web app. At some point, this was also random and serendipitous. We were offering a vendor-based trading platform to end users. They'd made a new release. And I was horrified to see that release because I remember that it only worked on IE6 in 2015 or maybe 2014. And that was completely unacceptable. At that point, that we would build our own online trading platform wasn't even a question. It wasn't even on a roadmap. Then, picked AngularJS. That turned out to be a disastrous decision. There was this Angular V1, V2 fiasco.
Yeah.
It was
JS and non-JS thing. AngularJS, Angular, all that stuff.
Yeah, the version change.
And they rewrote it in TypeScript and stuff, all of that.
Yeah, lots of things were happening. Yeah. And we found it to be, it's a complex framework also. It's not very easy to grasp. But V1 of Kite, our first end user web app in that sense, trading platform was written in AngularJS, Python backend, Redis and Postgres. But Angular, we immediately regretted it. It was so painful and difficult and hard. And just a year later, we rewrote the entire thing in Vue.js. Today, Vue.js is our our web app stack for the front end. And 2017 is when digital signatures became a thing. Now you could open a stockbroking account online. Prior to 2017, we'd courier you like a 40-page booklet. You had to do 40, 50 signatures, scan, print, Xerox.
I say direct way of doing things.
Yeah. And that was the only possible way. Yeah. There was no legal way to open an account online. It had to be offline. So you can imagine that the industry was very slow because who would want a courier? Then you make one mistake, miss one signature, it gets couriered back to you. So the drop-off rates were like 98%, I think. Then digital signatures happened. We could generate a PDF from the backend. People could just, with a few clicks, do a digital signature and no more couriering of, documents. That's when it really started picking up, online investments as a thing, post 2017. This was also a time when as the scale up happened, this was also a time when we started facing a lot of issues, downtime issues, because all of these things that we were building in-house were on top of legacy systems that the industry was using anyway, like OMS, the order management platform, the back office system. And the mega projects that we were handling was to take all of these pieces in-house and write them from scratch.
It was like glued to legacy, most of the things.
Yeah. So even if let's say you're a bank and you release a great looking net banking app, the underlying system would be, like a very legacy core banking system. And you'll have to start replacing pieces bit by bit. So the most amount of work that we'd done back then was, on the one hand, we were doing product engineering, building new features, new UI, new UX. On the other hand, we were replacing these really dirty, messed up legacy systems. And 9 out of 10 things that went wrong when we had downtimes were issues in these legacy systems which were completely outside of our control. So that was extremely frustrating. In 2013-14, I was experimenting with Go. It was a newish programming language at that point. And I was experimenting because, I felt like, I was just tinkering around. So we had this one particular use case for the trading platform where, you log into the trading platform, you see your stocks here in your watch list, they tick in real time.
Right.
So they can tick 2-3 times a second, and you can add a bunch of things. So that's a live TCP connection,
right.
WebSocket connection, and you have to push tick packets to it. Now, Python wasn't ideal for that. So I experimented with WebSocket libraries in Java, C++, a bunch of things, even Node.js, to find the right tool for the right job, but didn't want C++ to be added to the stack. You can build anything in C++, but it's complex and painful.
You have to write a lot of code, and
it's
hard to grasp the lot of code that is written later on, is what I feel with C++.
Absolutely. And people can write it in completely different styles using completely different sub-technologies, and it's not great in that sense.
Yeah.
And I was experimenting with Go, and Go was maybe a beta language. Oh no, I think it was 1.0, but it wasn't big. But I'd liked it, and it had great concurrency primitives, and concurrency is what you need to handle lots of live WebSocket connections. So I thought, what, this piece I will write in Go. And that became the first Go program that we wrote in our tech stack. So everything was Python backend, Python data crunching, Python web servers. Suddenly we had this one Go program that would accept WebSocket connections and stream.
Right.
And that gave me personally some confidence and experience in writing a Go program for a production use case. And I mean, our scale was really, today we have, let's say, 1 million plus users who log in and trade at the same time. Back then we had, let's say, 3,000. So you can't even compare.
Right.
And that 3,000 suddenly became 5,000, 10,000, 15,000, 20,000, 50,000 concurrent users, as online account opening went up. So Go turned out to be a great choice for live, low latency, not sub-nanosecond, not in that terms, but let's say sub-MS, request response stuff, super low on resources, easy to write, easy to deploy, and Go from handling just that one ticking piece, suddenly started making its way into other pieces. Some Python pieces we rewrote in Go.
Right.
And a lot of bottlenecks, lots of chokes that we were experiencing, disappeared. Then it turned out that Go was a great choice for the stuff that we were doing, which is handling huge amounts of requests per second, responding to requests in milliseconds. And suddenly most of the applications that we had, backend applications that were written in Python that were handling front-end requests and user requests became Go. And Go became an integral part of our stack. So that transition has been happening. And the biggest, complexity increased. We were running a large number of applications, not microservices per se, but services. So Kite, the trading platform, is a collection of, let's say, 3 or 4 large services, completely independent. Now, when you have services, they need to communicate, This is a data business. Do you have a customer database? The data has to be synchronized to the trading platform, to the back office platform, to the compliance platform. Synchronization, webhooks, etc., were becoming a pain. It's time to have a centralized message bus, and suddenly Kafka became a part of a centralized message bus. And the number of ticks, activity, subscriptions, etc. increase. So today, let's say we are broadcasting 50-60 million ticks per second to WebSocket connections. So when we were slowly growing to that point, we wanted ticks to be moved around in the backend through our systems before they were broadcast via WebSockets. Nats turned out to be a great piece. They're super easy to run, super lightweight. Just run, it works forever. And And the stack has largely stayed the same. It's Go, Python for stuff, Postgres, Redis, Kafka Nats, and all performing what they do best. Just because we are writing a new program, it won't use Kafka just because we have Kafka. We'll only use Kafka for synchronizing, one-way data synchronization or whatever. And lately, we've exhausted what Postgres can do, I think. So I don't think we want to store 1 trillion rows in Postgres, shard, etc. Then at some point, you're now fighting the database. So I'd been keeping an eye on ClickHouse as a database for the last 5 or 6 years, since pre-alpha. And I think 1 or 2 years ago, Cloudflare published a blog saying they use ClickHouse. And it was a beautiful blog. I really like Cloudflare's engineering.
I read the same
blogs.
as well.
Yeah.
The events storing
Exactly.
all the events
Correct.
they're doing.
Correct. So that was my point of validation for ClickHouse that I was looking for. And turns out ClickHouse reduces our storage space of several terabytes by, let's say, 90%. And queries that would take maybe 1 or 2 seconds, which is really slow for us, suddenly became 2 milliseconds. So it turns out it's a great database for storing massive amounts of immutable financial transactional data. So now that's a big part of our stack, and we're moving lots of things. So moving terabytes of data, moving hundreds of billions of rows of data that we've built over years to a whole new database, it's not an easy decision.
Right.
But we know that short-term pain that we will face right now will help us for the next many, many years.
Right.
So that's how the tech stack evolves. When there's a solid objective use case saying we need to introduce this new technology, it'll fix all these problems, then we introduce that. So today, if you look at the tech stack, it largely looks like this: Flutter for mobile apps, Vue.js for the web apps, Go backends, some Python backends, and lots of Python for data crunching, Postgres, ClickHouse, Redis. That's about it.
Right.
So we never think of concepts like microservice or monolith or whatever. You write software. You don't write conceptual architectural frameworks.
Right.
So let's say you have a problem to solve. And we work with Linux. All the programs are Linux programs. So you write a Linux program that works on Linux. That is super easy to deploy. If it's a single binary, great. If it needs 2 different programs, all right. But it'll never require 10 different pieces. There'll be no 10 microservices.
Correct.
So you start out by writing software that solves a problem. Then you start out by making it run on Linux because that's your environment. Then you probably add a web server. If it has to interact with the outside world. If it has to communicate with another program elsewhere, you evaluate: should it be a webhook, or can we just connect it to a one-way Kafka bus or whatever?
Correct.
And you start always from one Linux program and slowly expand it outwards.
Exactly.
As it grows, maybe it'll split into 2 or 3 programs. Maybe the technology will change. Maybe WebSocket will become something else. It doesn't matter. But you don't start out by saying that serverless, this, managed services, etc. And like you pointed out, we are very wary of managed services. Don't want to be vendor locked in. The regulatory agility that we need, as in there's a regulation, you have a 5-day deadline, you need to change everything. We need complete control over our data, over every aspect of our stack. So we don't use any managed databases. All these massive instances, database instances, they're all self-hosted. Just spin up a Linux system and you run Postgres or whatever, and it's all everything is managed by a team of, let's say, 1, 2 to 3 people.
Right.
And we self-host absolutely almost everything, even our HRMS, employee leave management system, employee intranet, everything. It's self-hosted instead of ERP Next, financial stuff, data crunching stuff, trading platform stuff. And over the years, we've rewritten and gotten rid of all the old legacy external dependencies and brought everything in-house. And I think we don't do justice to, let's say, Postgres. Beautiful, brilliant piece of software when we think that, who will manage Postgres? Most organizations will not have to store 500 billion rows. Probably you'll have to store 1 million or a few million rows, and it's absolutely fine. These are all robust technologies that you can easily run on a simple Linux system. So I think people are afraid to take responsibility for software. And the cost that you pay is vendor lock-in, humongous amounts of financial cost. I know that, so our CRM, right? We use ERP Next and Frappe heavily to build all these dashboards. If you aren't aware, it's an ERP system, Indian open source project.
Yes, I have seen.
Yeah. And we were so smitten by it, we so appreciated it that we became investors in the company. We funded it as a FOSS company at some point. So just the open source ticketing system that we've been using for many years, it looks a little ugly, but it's fast. 1,000 people log in every day. So, Zerodha has 1,000 people today. Outside tech, lots of people who have to pick up the phone and answer financial queries, compliance, legal, documents. And it works well. It runs on one server. Once a year, we log in to archive data. And that's 1,000 people, right? And I know how much SaaS ticketing solutions cost per user.
Right.
Just on our CRM, just on our ticketing system, we are saving millions of dollars every year, just on these two things. And we self-host, I don't know, maybe 100 different things, right? Lots of things. And it's the same 30 people who build systems, who build end user products, who also maintain these in-house systems.
Yeah.
And maintenance is, sometimes you log in once a year. Sometimes it's running for many years. You don't have to. Yeah. And people also, I think it's a tendency to not look at risk holistically. Some systems can go down. I mean, let's say it's an internal dashboard. So what if it's down for 10 minutes or an hour? It doesn't matter. It's not going to affect anything. But that everything has to be always up 100%. We need a managed SaaS for that. That FOMO, that irrational FOMO also drives a lot of these decisions. But for sure, we are a profitable enterprise today, and a significant amount of our profit margins come from our decisions to self-host and keep the stack lean.
Right.
Our AWS bill, we use AWS heavily for our hosting applications, is laughable. It's not even, our annual bill is probably not even like an Instagram campaign for many startups. That's how low the bill is. And all of these things play into the future of the organization, right? If you want a sustainable organization where tech is nimble, you're regulatory nimble, you're actually making profits, and you just need a few people to handle and run everything, it all plays in. So it's the tech stack, but not specifically the tech stack. It's the first principles used to construct this tech stack that has really mattered.
Yeah. So I absolutely love that, the Postgres example as well. I think, if you are able to scale up to million, and then if you reach 100 trillion, then you'll figure something out in that space. And I have done self-managed, like I have seen open source projects do their own bug tracking, something like Redmine or Bugzilla. Works fairly well. Like, they're probably tracking more bugs than a lot of companies at fairly large scale. They're probably tracking more bugs than that via those things. Probably one $10 server, and they're running it on.
That's what we do. GitLab. Sorry, I forgot to mention GitLab is a part of a stack. That's where we host all our repositories. That's our CI/CD system, bug tracking, issue tracking. Works really well. Self-hosted instance of GitLab.
Yeah. I have burnt my hands on managed Postgres. So we used to run Postgres on our, and this is talking of since on 16, 17, our startup. And we did not get into AWS because initially it just felt like, okay, whatever we want to run, if we can just... we were bootstrapped. They didn't have a lot of money and no investments, nothing. And we were fairly young. So just to take the risk of, okay, if you put something on AWS, there are horror stories out there, blogs of people running millions of dollars in bills. So start off something like DigitalOcean. Like, okay, if you take a $5 server, you're not going to spend more than $5 because it's a VPS. It's not auto scale or anything. So we started off like that. And our databases used to be hosted on our own VPS, right? And then a couple of years later, they pitched that we have managed databases now. And they poked and prodded us for a few months. And like, chalo, theek hai, we'll try it out. So we tried it out. Problem happened. Someday, site was not working. But things went down. And you're like trying to debug, okay, what's happening? Why it happened? Okay. Everything seems fine. Every time we restart the entire VPS, everything works fine. But if there's some spike on the DB, the managed database, it resets the connection. And after it resets, somehow does not connect. Okay, we're trying to figure out what's happening and keep debugging. A few minutes later, we are like, okay, if we copy the URL from the API, it works. If we copy the URL from the dashboard, it does not work. Okay, strange enough. So we look at the URL that's on the dashboard and the one that we just copied, like it's the same. Then there's a copy button on the web clipboard button, right? We click on that, and we copy and we paste, and we see that what is actually shown is not the same thing that is copied, because when we click on the copy button, it actually makes an API call and gets a fresh one. But the string that is shown there, if you just drag with your mouse and right click and copy, you get a wrong one. But if you click the copy button, you get the right one. And then for an hour or so, we did not think that something would be wrong with their database, because so many clients are using, they must be right. Something must be wrong with us. If you have been hacking around, the first thing you blame is yourself. Something must be wrong in your code. Some glue not working. Then we're like, no, we'll just move back our DP. We'll manage it ourselves. This does not happen when we manage it ourselves, at least. And we realized when we moved back, we saved a lot of cost and better reliability, because this does not happen. So that's definitely. So you're talking about GitLab as CI/CD as well. I think a lot of people do focus on both in terms of learning and sort of trying to establish pretty elaborate CI/CD setups. I code review something here, automatically will get deployed, everything will work, and all of that stuff. What I have so far found out, I might be wrong, is that people spend a lot of their day trying to chase that utopia without actually achieving that utopia.
I agree.
So how does your CI/CD stack look like right now? How do you deploy things and all this maintenance and stuff? How does it happen?
It's quite simple. Like you said, people put in a lot of effort into the process of achieving the finest, most automated, slickest CI/CD pipeline. And that's just wasted effort. At the end of the day, you're working on software, and there's a new version of the software, and you have to get it somewhere. That's about it. I mean, everything else and a simple, good enough path. So our CI/CD system is actually quite simple. We have a job file for many of these repositories, and lots of them, we've created a template that many repositories can use so that people understand how different repositories are working. So for Go programs, when stuff is pushed to GitLab, there's an automated, lint plus test that runs, and just a common sense sanity check. Then there's a build step that compiles the Go binary and dumps it to S3, some designated bucket.
Right.
So that is really the build system really done. And then we have another deploy step. And for critical applications, that is manual for us. We don't really care about, deploying 100 things in a day. But every deployment, because of the risk, we are extremely, extremely, extremely careful about deployments.
Right.
So insane amounts of testing, weeks and months. So that step for most of our critical apps is manual. You have to go click a button, that little play button on the GitLab UI. And that is when the actual app will get deployed. Now, the deployment environment, we wanted a uniform environment for all our applications, and we tried out K8s as a uniform deployment environment where people can write a manifest YAML file, and it'll 80%, 90% it'll work for all different projects. Because otherwise people roll their own deployment build schemas, and it becomes non-uniform over time. But that didn't really work out. K8s turned out to be insanely complex. There were, YAML manifest within YAML manifest within YAML manifest, and we had to write tools to make sense of these manifests. So that pilot, we phased out. And sorry, I forgot to mention this Nomad, HashiCorp's Nomad as a orchestration plus deployment stack is something we piloted, and we are deploying everywhere now.
Okay.
So we've written and HashiCorp's Nomad is really simple. It's not like K8s, which is like a full-fledged cloud operating system in that sense. Nomad is an orchestrator. You say you need, 10 number of EC2 instances, and this binary should be copied to these 10 instances, and they should run, and port 5000 will be exposed. It's simple. And the Nomad job file kind of looks like a simple Nginx file also. Very easy to understand, probably 20, 30 lines of code, and you have this environment. So this binary that is dumped in S3, when the deployment happens, this Nomad script is run, and Nomad is keeping track of n number of EC2 instances running for, let's say, Kite Ticker, or some other program requires, these other instances. It'll instantly pull the binary from S3 and copy to the right location via SSH. Nomad agents run, and it'll send a signal to restart the app, and deployment happens. So Nomad is great in that sense, because all that orchestration of pulling your program from somewhere, copying it to the right EC2 instances, managing EC2 instances, or managing an automated restart, all of that Nomad handles. So there's that. Before we had Nomad, before we had K8s, It was just manually created EC2 instances, and some simple script would copy the program, dump it there, and do a restart.
Right.
At the end of the day, no matter how sophisticated your CI/CD system is, it's a Linux program that is going to be killed or SIG-hubbed or restarted. That's it.
Yeah.
So you don't change your perspective from that. So we use Nomad to clean it up and make uniform deployment templates across all our projects, so people know that what is happening, and it works well. So CI/CD is really simple. Upload to GitHub, test runs, build is created and pushed to an S3 bucket. That S3 bucket could be an EC2 instance. It doesn't matter. It's all simple, pluggable. And from there, when we press the deploy button for critical apps, Nomad will pick up the program binary, Go binary or a Python program or whatever, copy it to n number of EC2 instances that we've configured to run, and send a reload signal.
Right. Makes sense. I mean, I have gone through that go to Kubernetes and come back thing myself as well. I figured for me it was like more drastic, like go to Kubernetes, come back to just Docker compose file. That's enough. Like one Docker compose, deploy everything on a single server.
Yeah.
That would work. So that's great. And I've been asking a lot of questions. I'll just have one last one. Right. So this is about, and I had seen, I think last year's HasGeek event where I talked about scaling with common sense.
Yeah.
Right. I think there's a last piece around that tech stack I would want to ask, which is not about particular technologies, but let's say you've seen, starting with, few hundred users to millions.
Yeah.
Right. I mean, scale obviously across all of your systems don't work linearly. Like everything does not just scale to 10 times because users scale to 10 times.
Yeah.
Nevertheless, when somebody's building software, right. I mean, there is obviously the age-old debate about premature scaling and all.
Yeah.
But pragmatically, what are some of the things one should keep in mind? Like what will happen if things scale? What should I not do so that I don't burn myself with scale?
Yeah.
But also like not overcomplicate things.
So again, no easy answer.
Yeah.
It's a first principle based approach. Your decisions have to be as less wrong as possible. It's very difficult to make long-term right decisions with technology.
Right.
So as less wrong as possible. Now, let's say you need a database and you pick Postgres, which is battle tested. Now that's actually a decent decision. You know that people have scaled Postgres databases to massive scale. So it's not a complete unknown. Redis, for example, if you were to pick some sort of a cache or in-memory database, you could just pick Redis because it's so well documented that Redis is battle tested to kind of work forever.
Right.
So when you pick these pieces to add to your stack, you pick pieces objectively and carefully.
Right.
And assembling the stack is like 80% of the work. If you pick the wrong database, then you're kind of screwed. You will have to rewrite your app, you can't migrate. So just careful consideration and in which you pick robust technologies, right tools for the right job before you even start writing code is that. And maybe there are other considerations also. So I'd cited this example of using Go, which was a hobby tinkering project for me to write a production ticker program,
right?
A live market ticker for a trading platform. Python was a stack, and there were other things like C++, etc. But this just turned out to be the best tool for that job. Although it wasn't a part of that stack, decided to introduce that language into the stack. So sometimes you have to make those decisions. Maybe you know Python really well, but the task at hand requires something where Go is better suited. So maybe that decision to pick the right tool for the right job, foregoing our familiarity, that also factors in.
Makes
so
sense.
It's a bunch of these things. Then of course, you shouldn't start out, people have this tendency to build things for 10 million users that will never ever come. So we have to be extremely grounded and realistic.
Right.
So that realism will automatically translate to an architecture where it's good enough to scale to a certain point. And after that, if you really need to scale, it would be modular enough to, kill, replace, swap, etc. But if you are going to build something for 100 million users or 10 million users on day one, your entire architecture, you're going to focus so much on those invisible ghosts and problems that you will never be able to focus on your business logic or product. So keeping things modular. And speaking of modularity, we also touched upon risk earlier, where people think that every system has to be 100% up all the time. That's never the case. So that is also an important factor. When you design software, when you design an architecture, we should allow modules to fail gracefully for worst case scenarios. For example, on a trading platform, not all features are equally important. Maybe there are a lot of, let's say charting features, etc. Worst case scenario, people should be able to see their portfolio, buy and sell, etc. And maybe a certain charting feature not working is acceptable.
But the site should not crash because of that.
Exactly. So when you think of it that way, when you look at your software holistically and decide that this is the most critical function, this has to have 100% uptime.
Right.
But this can have 99, this can have 98. This doesn't actually matter. Then you automatically architect your system to fail gracefully and modularly. Just because this fails doesn't mean the entire thing should fail. And just because this fails, it doesn't mean that your business is affected. So that grading modules of a product or a technology stack and letting them fail gracefully will also make your system robust. By doing that, you're automatically making them pluggable and swappable. So we are swapping out Postgres for Clickhouse today, despite having massive databases. But that's how it allows, that modularity kind of allows you to do that.
Right.
And you don't mix concerns. Like if you invent, let's say you pick a NoSQL database, and if you have to do a lot of relational reporting, you end up writing huge amounts of business logic and app code in your app.
In-memory joins.
In-memory joins. You reinvent SQL in your thing. Then that's not modular. You can't swap it out. You put in so much effort here. So you should know that, SQL is the right thing to do it, and I'll, offload it to SQL. Because it's SQL, tomorrow when you switch, let's say swap out another SQL DB, with minor tweaks, you can port all your business logic. So it's being modular, and I'm not talking about monolith, service, microservice, but modular in architecture is important.
Right.
And this modularity should never be visualized in terms of hosted services. Oh no, function here, edge thing here, some, SNS queue here, whatever. It should be visualized in terms of, let's say, Linux software.
Modular in design rather than modular in implementation. I mean, if it is in design, the implementation will follow suit.
Exactly. Modular not in terms of external services, but the software's own architecture. So whenever I see architecture diagrams where someone is proposing a product and it's full of, let's say, managed services from a certain cloud, it's there's a high probability that it turns out to be disastrous because they've designed their software to be entirely dependent on completely external facets, which you have little control of. But if you're writing software, you should focus on software, make it as self-contained as possible, and only give away control to external services and resources if you absolutely need.
Right. I think a factor there, I would say a lot of people do not consider also is, I was giving a talk recently at a conference about microservices, and I was saying that, and then there was a nice case study Amod had made on Twitter, which was like, if you insert load balances, let's say you have a monolith, you separate the data layer and the controller layer out, and you have a load balancer between them, so that data layer has its own load balancer now, right? Suddenly the architecture looks, nice, I have separated my concerns, and if somebody hits the controller layer, it will probably not fail, I can scale it more, data layer is separate. But then without giving any other context, like discussing anything further, how much does this affect the availability? And it will, like, if you just simply take like P99 in every layer, you just added a new layer, it will go down. It does not by default go up. Now, you doing that extraction, if you actually put in effort into making the availability higher because of that extraction, maybe you don't need to reach the data layer for a lot of use cases, then maybe you get an advantage. But if you don't, then the default is you lose out.
Absolutely.
And then the other piece is also, and that was part of what I was explaining in that talk, is like there were a lot of people who were founders of tech companies, and then they were talking about like whether they need to do microservices or not. And I was telling them that what's very important is the boundaries you draw in your system, you need to draw the correct ones. I was giving them an example, like if you have a blogging app, if you have, let's say, the API layer, the business logic layer, and the data layer, if you separate at this way, like all the APIs in one service, all the business logic in one service, all the data, what will happen is between them, each hop will have a serialization penalty. Whether inside your system or outside, the penalty would be there.
Absolutely.
Right. But if you split by features, let's say, and let's say if user sign-in is not available, so my user service is down.
Yeah.
But still people can publicly, like index the articles, Google search works, and your article reading works.
Yeah.
That's a much better split. You don't get the penalty of the deceleration serialization.
Yeah.
Second, you split it across things which you need and not need, rather than
Exactly.
layer.
You have to grade those modules to fail independently and as gracefully as possible.
Yeah.
So dependency is one of the biggest bottlenecks. A dependency, and every network dependency that you have is prone to disaster and failure. And if you have a system where you have lots of services, all of them speak to each other over network mesh, etc., right? Something goes wrong, you can't even debug. So software should be as self-contained as possible by default. So that's why it's problematic saying, I'll start out with a monolith or I'll start out with a microservice architecture. There's no such thing as a microservice architecture that works for all software, all people, all teams, all business, all environments around the world. It's just a loose name. It's a vague name for a loose set of concepts, right? You may end up writing many services. You may end up with just one service or software, but you don't know. That entirely depends on so many factors that are so private and intimate, to a certain business. So there are no universal architectures that just work.
Right. I think thanks for answering all the questions. The last question, one of the answers, the takeaway, I think really great, where you said that, let's not think about writing microservice, let's write software. I think I hope that becomes a very important takeaway from this. But once again, thanks for coming here, spending the time and this conversation. I really, really hope it will spark some motivation to build things for people, build software, write software.
Absolutely. Thank you. Thank you so much. It was a fun chat.
Thank you.
And I think I vented quite a bit. So, yeah. Thanks for providing me with an avenue to vent. Thank you.
Sure. Thank you so much.
Yeah.